All right. So I have gotten done grading all of the exam two portions. The grades overall were at a point where I don't think I'm going to do any more adjustment to the grades. If you have any questions about your grades, email me and let me know. But I don't think there's going to be any more adjustments. I went ahead and there was one question in there that I pretty well gave credit for no matter what, because the wording or the grading of it was not being done very well. And then there were a couple different places where I had partial credits in the written one, especially. There was the one question where there was a partial output of it in the key there was, and the answer key there was not the last two lines, but hopefully I think 85% of you got that one correct anyway, so I don't think that would have been a issue, because the rest of the outputs, none of them were anywhere near this particular output, so you shouldn't have wanted to select any of those anyway. But that's the exam two. This week we've got reading quiz for chapter 10 due this morning. If you haven't turned that in, you should get that in before 11 p.m. It is due now, so if you had not done that, you should go ahead and get that done. The word of the day today is purple. That will go with lab 19's submission. Today we'll do this lab 19, the color lab. I'll go over about half of that one in the class session here, and then let you finish the rest for homework. This week also, apart from that, we've got this Wednesday through Friday period where there's going to be this CS149 assessment. It's a quiz inside of Canvas, and it is worth 30 points. It will be a like exam two written, and it's an opportunity to get back some points. It's worth 5% of your overall grade, or those in-class quizzes are worth 5% of your overall grade. So if you need some points, that's going to be a great resource to get it. This is a closed book, closed notes honor system here in effect, but you should be taking this one and not having any extra pieces of any kind of information while you're taking it. It is a 22-minute quiz, and it will be timed inside of Canvas. So make sure you're taking that as a 22-minute quiz. Those who have extra time will have 33 minutes for that quiz. So make sure you're setting aside time to take it. When you take it, you should take it one shot and not try and come back to it. So finish it in the 22 minutes that you're given, or 33 minutes that you're given, and then turn that in by Friday at 11:59 p.m. So make sure, again, this period right here, 11:59 p.m. on Friday is when that is due. And then Sunday at 11 p.m., your homework 10.1 through 10.3 are due in Auto Lab. So that's the breakdown of what is due this week. So we've got Color Lab that is due Wednesday, tomorrow night, 11 p.m. Friday by 11:59, you need to get done the 149 assessment piece. So make sure you've done that piece and gotten that done. And then homework 10.1 through 10.3 are due on Sunday at 11. You still have until 11 tonight to also 9.4. So if you still have questions on that, I will be here after the normal class session for some office hours to answer any questions you may still have around that, or you can email me or try on Piazza. Those who are having some problems with the Eclipse check style, there is another check style file that is out there on Piazza. If you go to that, you can download that file. I'll probably try and replace the CS149.xml file that is in the check style lab with that one, given that this other one causes Eclipse problems, and I don't want to have that happen next semester. So I think going forward, that's going to be the new file that I use for there. All right, let's get into the lecture portion for today. I wanted to get into a couple different things here. Let me go ahead and share my window out, screen one. pull this out here. All right, let's just do that. All right. So today we're going to get into the introduction in chapter 10 to the third stumbling block or roadblock in CS149, which is the idea of classes and objects. So this is, again, the third area where a lot of students are going to struggle to understand some things. You've already hit the first two, which would be the methods piece, which would be the first one. The second one I consider to be loops and arrays. And then the third one here that I see most beginning students struggle with is this idea of classes and objects. So if you've made it thus far and are understanding things to a good degree, congratulations. This is the last hurdle that you need to get over for CS149. It, however, is a pretty big hurdle. It's where a lot of people will have exhausted their level of high school programming or any kind of previous programming experience. A lot of times when you learn how to code in high school or in other areas, they don't get into object-oriented programming or classes and objects very much. I teach from a perspective of what we call objects last, where I teach object-oriented programming last in a beginning programming course. A lot of people follow this approach. It's one where we teach you all about the language constructs, some of the language syntax, and then also a lot about if then else, conditionals, loops, all of those structures before we actually get into what are known as objects. So now we will go into, from this point forward, into this idea of object-oriented programming. So we've got this idea where we will be taking objects and working with these objects and manipulating these objects. So we're going to design these classes now, whereas we were designing these classes with just a lot of different methods that were run semi-sequentially or calling in a very programmatic way. We're going to now have objects that we create that can be interacted with in a variety of ways or in a variety of method calls that will go against these objects, and we'll have to create objects. So first thing here, when you define a class in Java, you're defining a new reference type. So this is, again, one of those types where we've got the arrow, the pointer, where we've got a pointer over to something, and we've got a memory object that we're creating, or a space in memory where we're allocating space for something to be stored. In this case, it'll be a die object. So, for example, this die class below is, each object has its own attributes, which is are the data elements, and then methods, which are the code pieces. So if we take a look at this first model here, we've got the die object here that Dr. Mayfield has created. This die object, we're going to see these things that are called universal modeling language, or UML diagrams. These little diagrams over here, this idea of this class name up at the top will have all of the attributes here in this second little, and have a good portion or all of the methods that are involved in it, the class, underneath in this third section to the bottom. So we've got the top section, which is class name, the middle section, which is the attributes, and then we've got the bottom section, which is the actual portions of the die object, which will be the methods here. All right. So let's get to it here, and we're going to take a look at these pieces. So the questions we have over here, and the answers are all in the notes section down here, so you should be able to find all of those. So what are the attributes of the die? So the attributes of the die are only this face value, this integer face value. So when we have this die object, we're going to have this die object that we can roll, and we can have face value that's on that die object, say 1 through 6 in an integer values. So, and then the methods that are involved with this are going to be here. The constructor here, as we call it, this creates a die object. Then we've got this idea of rolling the die, which is a method, and then the get face. So these are the three methods here that are involved with the die object. So in this class diagram here, this UML diagram, what are the minus and the plus symbols? The minus and the plus symbols are to declare this idea of private or public. So this is the last piece in that big mantra that we learned at the very beginning. This public static void string array args in the main. So that's that public aspect of it. So we're going to get into the last piece, the static, non-static piece next week. So we will finally be unpacking the entirety of that mantra of public static void main string array args and understand, hopefully, every piece of that. So this piece today is this idea of public or private. So this minus sign in front of face here shows us that this is a private attribute. So what that means is that we cannot access this attribute, this face value, outside of the die or the die class. So if we're talking about a die object that we've created, then we cannot access the face value outside of the class. What we can do, however, is run the methods that are associated with it. For instance, this get face value that is going to, if we go die.getFace, we will be able to get the face value out of there. We use these methods that we call accessors or getters to get information out of a class. And it's so that we don't ever touch the actual attributes inside of a class. This allows us not to have leaky memory or somebody else changing some of the things about our class without us knowing. So if we allow this to be public, people could come in and change that die face value without us knowing for a particular object, and that would not be good. This, in fact, is one of the biggest ways that hacking happens on the internet, is these kind of leaky memory areas or leaky attributes where somebody has forgotten to make something private and has made it public instead, and then somebody can come in and change a value. A lot of what's going on right now in this idea of Zoom bombing inside of this Zoom app that is being used like WebEx to do a lot of these online classes and things. That's what this type of thing is, this Zoom bombing, where people are hijacking into sessions because they know private attributes of that session or are guessing at those private attributes to get into a session and then be able to put different pictures into there or inject in different things into the chat that is unwanted. So in order to have better security, the Zoom app is trying to close up these holes. So that's a pretty realistic example right now of what's going on. So notice how the roll method refers to face, yet that variable is not declared in the method. And why does this work? It works because we can access the actual methods over there, the attributes inside the class. The roll method will then change the face of the die object. So let's say we're in another class and the main method, and we want to declare a die object named Lucky. What's this declaration statement look like? So we start over here with the die referencing our class, and then we say we want to create a new die, and we're going to call it Lucky, and then we're saying it's a new one. We want to allocate memory for a die object. So this is die Lucky new die. That's how we create a new dice or a die object that is called Lucky inside of another. Say we had a casino that we were running that we wanted to have dice, and we wanted this one die to be a lucky die. That would be how we would declare that. All right. So in here, what would the statement look like to instantiate the die object? So again, here, I'm going to call this one my die, and it's die my die equals new die. When we instantiate an object, we're actually calling a constructor. So we're creating a new object. This method has no return type and the same name as the class itself. So we're calling this die constructor down here. You usually want to, in your java.comments, label your constructor and say constructs or constructor or something like that to let people know that that is the constructor for your class. So what is this guy going to do? This constructor class for the die is going to call the roll method, and it's going to roll, and it's going to set the face value to a particular value, a random number from 1 through 6 over here. So that's what it does. It creates a die object, a new die object that it will, in this case, my die, that is going to have a value from 1 through 6. All right. So in number 7 here, what's wrong with the following code fragment? So if we go int value, value equals die.getFace. So what happens is we can't call this getFace this way because this is trying to call it in a what we would call static way, because it is trying to call it without a object. So in order to call this, we would actually have to call it this way. We would have to need to be called like this. We would need to go value equals my die dot get face if we wanted to set this value. So that would have to be how we write this particular call. We'd have to have an object. We're going to say my die from before, and we'd have to call the get face method against an object here, because it is declared as non-static. So this get face is not static. We have public static usually, but in this case we don't have static. We have a non-static, which means we have to call it using an object versus calling it directly. So again, it is static and can't be called against an object, so we need to set the public void set face int new face, or this face equals new face. So that's how the other piece here, if we wanted to add a method in here to allow us to change the face value directly, this set face would be how it would be written. All right. So again, this unified modeling language, UML, allows us to provide a way to graphically illustrate the class design and independent of the programming language. So this can hold for C, C++, C#, any Python, any number of languages that are object-oriented. So we can use these UML diagrams to write a class. In this case, we've got the circle class. One of the things that we're going to be expecting you to do on the final exam is to be able to take a UML diagram and to be able to extract out the components of that UML diagram into code and vice versa. So if I asked you to draw a UML diagram from a set of code or from pieces of code, you should be able to fill in the blanks for that UML diagram as well. So make sure you understand how to do that and how to translate between a UML diagram and code, and from code to a UML diagram. So finally, we take a look at these last few things in the second model about the circle. Again, we've got what circle. So the attributes are the radius only here as a double value. Then the methods are the constructor, the area, circumference, get radius is a getter or accessor, and the set radius is a setter or mutator. So you'll hear us use those words in computer science interchangeably, getters, setters. I tend to use getters and setters because it's easier to understand. It's a little less terminology or jargon-like. They're also called accessors and mutators. So you need to know the difference, and those are good vocabulary type terms that might be good to understand for the final exam. You might hear those or see those again, or be asked what these items are or these methods are within a set of code. So number 10 here, based on model 1 and 2, what is typically public and what is typically private? So what you usually find is that the attributes are typically private because we don't want to be able to change the attributes outside of a class. This is especially true, and I think there's an example on the website for a credit card. If you had a credit card PIN or a credit card number, you would not necessarily want some of those things to be publicly available outside the class. You would want them only to be available inside of the class to be edited or to be used. So that's the typical way you would set up classes. So how would you declare a variable named unit that is a circle object? And how would you instantiate a circle with radius 1 and assign it to unit? So here's how you would do that. You would go circle unit equals new circle sub 1. And that's setting it up and passing the radius of 1 into the circle constructor here, as you can see in the plus sign there. So, all right. The next one here, 12, we're in a main method that creates a circle object with radius 2. So we've got a circle object that has a radius of 2, and we're going to display its area and circumference on the screen. So this main method here is what you would use to do that. You would go circle circ equals new circle sub 2, and then system out print lines circ.area and circ.circumference. Because we're passing no parameters to these methods, we're using the radius that is part of this object to get the circumference and the area, and those are going to be returned when we call it in this fashion. Then what would we have as the contents of the memory at the end of your main method? So here's the main method's memory stack diagram. You have a pointer circle to a radius that has a radius inside of it that it has a value of 2.0 because it's a double. So that's what the memory stack diagram would look like here in number 13. So number 14 here, write the complete code for the circle class. When the value of radius is set, make sure it is not negative. If it is, set the radius to 0 so that we're making sure we have positive radiuses in circles because that is an attribute of circles. And then recall that the area of a circle is pi r squared and the circumference is 2 pi r. So if you go into this piece here, you can actually go and find the code for this class. We've got our circle here where we're setting the radius, and we're calling that set radius. Basically is saying if the radius is greater than 0, then this radius equals radius. Otherwise, this dot radius equals 0. And when we say this dot radius, we're referring to this particular object that we're working with now versus that object, which we are not working with. So often I will, in creating variables, other or that are the ones that I like to use for the names of the other objects that we're comparing something to, that or that circle, this circle and that circle. So that's how we would refer to those things. All right. That ends what I wanted to do from the lecture standpoint. Let's get into lab 19 a little bit. And then the other thing I'm going to do to wrap up class is I'm going to go over, since I got a lot of different emails from you guys about testing and Eclipse, I'm going to go over and create another couple more test examples inside of Eclipse for some more of these coding bat kind of assignments. So what I'm going to do is I'm going to set up a few more, I think I'll take 2 more examples from the coding bat side, and I'm going to set up tests for them, and then I'm going to set up the code and code through the solution for them, and then kind of show you inside of Eclipse how the coverage is done. So I'll do that at the end of this, but let's go in and get into lab 19 here. This is the color lab. So in this lab, we're going to create a class named color149. Java already comes with its own color class, but this is our color 149. So we're going to create this class. we're going to download a copy of this main.java. So I'm going to go in here and open this in a new tab, actually. And I'm going to actually come into here in Eclipse, and I'm going to create a new Java project. I'm going to call it Lab 19 Spring 20. You can just call it Lab 19. I'm doing this because I already have a Lab 19 in my workspace here. So I'm going to use the project folder as root for sources and classes. This will keep it so that I can use this in Eclipse or go back to JGrasp if I'm not feeling comfortable with Eclipse. I'm going to go ahead and keep, for a lot of our examples in the next couple classes, continue to use Eclipse. You don't have to use Eclipse. The only thing we wanted to do in this first semester of computer science 149 is really just introduce Eclipse to you, but not actually require you to use that. So yes, and I will be recording, posting this recording to the Canvas site. So if you feel like I'm going way too fast, which is almost always the complaint I get, or the mention that I get about my speed of class, then you will have this available for you after class. So know that this will get recorded. I'm probably going to do this for most of the classes, and I will probably, inside of the particular lecture, like for the last class, I put it in there yesterday. I finally got the recording. For some reason, WebEx takes quite a long time to process these recordings, and so it takes about half a day for them to generate the recording of this class. So I don't know why it takes that long, but maybe it's because a million people are using WebEx right now, teaching online. But I've noticed this has been really slow to get out there. So I apologize if it takes me a little bit to get those out there, but hopefully they'll get out there in a more timely manner. This one, hopefully I'll try and get out by tomorrow. It should be available by then, and I'll put it out on the website. All right, I'm going to go into next here, and then I'm going to go finish. Then I want to, inside of my project here, I'm going to create a new class. I'm going to call this class main. This is the class I want to use from, I'm not even going to worry a whole lot about it because I want to just take this stuff over here. I'm going to copy and paste it into here. So, and then I'm going to change the name here to my name, and then the due date over here to 4-8-20, and save this. So this is not going to compile right now because it's looking for this color 149 class. So I'm going to go ahead and come back over to here and then close this out. Then I need to download a copy of this class, this color 149 class. So I need to create this class, file, new class, and I'm going to call this one again, color 149. I won't make a main section because I don't think I need one. Again, I'm going to take most of what's in this other class that's out here, copy this, and I'll paste it into here and save it. All right. So now that I've saved this class, this main class over here is a lot happier. It's got no more red X's on it as we come into here. So it's got a couple warnings. The local variable here, C9, CC9 and CC8 are not used. That's because we're not doing anything with them yet. So that's going to give us that warning there. But we've got this color 149 class here, and this is what we're wanting to work with. Make sure you change to your name, not that. And then the due date, which is 4-8-20, and then I have abided by the JMU honor code. And I'll save that. All right. So what I want to do is I want to go into read the documentation for this. This documentation, this is the Java documentation. So I've got this color class that I've created. I'm going to have some constants in here for black, blue, cyan, green, magenta, red, white, yellow, the standard primary colors here that we have, the basic rainbow colors, as it were. So each of these components, so how a color class is defined is we're going to have three different components into it. We're going to have a red, a green, and a blue. So those three numbers are going to create a particular color. So in order to create this, we're going to have this constructor here. It's going to have a red value, a green value, and a blue value. We're going to pass it 3 integer values. So we're going to also have several methods we've got in this class. One is to add. So this method returns a new color 149 value that is the sum of this color and the other color. So we're going to take 2 colors and we're going to kind of add them together. This brighten one is going to return a brighter color than the color 149 value. Same with darken. We're going to take one color value and we're going to create a new one that's a little bit darker than that value. Dim is going to create a dimmer value. This is semantics in here as far as what these actually are doing dim and dark wise, but they're going to have different values that they manipulate the piece with or the color with. Equals is going to be one that tells us if one color is equal to another color. In order to be equal, these colors are going to have the same red, green, and blue values. So we'll have to check all 3 values when we do our dot equals method. This lighten method here is going to lighten a color. And we've got this last one down here, this sub, which is a return a new color 149 value that is the difference. So subtracting one color from another one. So we had add up here. We've also got this subtract. Then we've got this toString, which is going to return the color or a string representation of the color that's red, red value, green, green, blue, blue. So those are going to be the hexadecimal digits that represent the color. So for those of you who are graphically oriented, these are your hex colors within things like Adobe Photoshop or that kind of thing, or out on the web if you've made a web page. Those hexadecimal values, for example, the JMU official purple is 450084, and I only know that because I work with that every day and have that memorized because that is part of my job and a big portion of what I do on the other side of campus. So we've now looked at some of this documentation, gives us a good idea of what this color class is supposed to be doing. Let's get into the piece here. We're going to run today's program from the command line. You won't actually have to do that or necessarily have to do that, but the idea is that we would be able to do this at some point to run this to get it to do some things. I'll go ahead and do that just so that we get this idea. Let's go desktop, and I'm going to go into my CS149 folder. Actually, all right, let's go into labs, CD lab 19 spring 20. All right, so I've got this in here. I've got my color 149 and my main in here. Now, if I run this statement, all right, so that's going to compile everything in there. Okay, so we're going to do Java main. Let's send the output to here and see what we get. So this is going to give us a bunch of hexadecimal things and HTML code, basically, that will give us a web page. So then if we come out here and run this Java main and direct the output to output.html, this is going to actually go to a file. Go here, I can do this and open up a window here. And if I open this up, this is going to give me the hexadecimal representation of the color and then what the color looks like. Right now, since we have done nothing, all of these are black to kind of represent that this is in a base state or a state where everything is not set. So everything's set to 0, a default value of 0 here. So let's go ahead and start to get to work on the lab here. What we're going to do at the lab is look at the parts of the lab and create the rest of these methods. Number of constants have been defined. They're public so they can be used outside the class. So that's where we wanted to be able to use these. So we've got public static final color black. So we can use this as in color 149 dot black. So in the main over here, we can use this as color 149 dot black. This is how we reference this constant in the main of another program. This main.java is allowing us to use the color 149 black value that we've assigned over here. And that color 149 creates a color that is 0, 0, 0, or the absence of all colors, which is black. So we've got that over here. Let's go back to here to see what we're supposed to do with these. Note these are referenced in main. 3 instance variables are defined. So for each object that is created will have its own copy of these instance variables. These instance variables are private, so they can only be accessed by methods in the class. So again, these instance variables that are in the class are these private instance variables, this red, green, and blue. So these are components of the 149 color object and can only be accessed inside the class here because they are declared as private here. The methods toString, add, and dim have already been defined. So let's take a look at those. Well, we've got to fill out these make me sections here, but we've got this toString. So it's going to take the red string, green string, and blue string, and it's going to say red string equals integer dot to hex string of this dot red. And so we're going to change that to the hexadecimal representation of red. And in this case, it's going to be 0 whatever. And this is also the green representation in hex and the blue. So we're going to have pound, or this hash mark, and it's going to be pound 000000 in that case for black. So that's what the toString does, and that's what we would be calling over there, is to get the toString to do that. So in main over here, we are in fact calling a toString value to get the black value out for these items. So we are going to call that toString in here, or in this case, this out.printf is to out, which is the output method that we're going to use. And we're saying color black, and then we're going out here and we're doing the black color and then printing out what the black color looks like. So these are the descriptions of what we're doing over here. We've got the toString that we're calling the color.toString, and then the color name. All right, let's get back to this lab write-up here. So we want to do the methods that have already been defined. Look at these methods, ask anything that you don't understand. So if you want to take a look at some of these methods here, what are the other methods that we had in here? We had an add method that is already defined here. This method returns a new color value that is the sum of the color and another color. The value of the red components of the two colors are added as are the green and blue components. Any result greater than 255 is set to 255. So that's the one thing we want to keep in mind here. So if we are adding something and it goes over 255, we want to cap it or set a ceiling value of 255. We've also got what we call a floor value of 0. It's never going to be a negative number. So if in the other subtract one, we've got a piece here that we're going to have to make, we're going to want to take the add kind of idea and do the same thing where we're not allowing it to go below 0. In this case, we're not wanting it to go over 255, but we're going to accomplish that with some things that we're doing in the constructor here, where we've got in the we're going to rely on the constructor to be less than keep the bounds between 0 and 255. So let's start by making this constructor. So if we have this, we're going to say, we want to say int my red equals red component, int my green equals green component, And you'll want to do this. It seems a little redundant but you don't want to mess with, and you've seen this before, I think, in a couple of the other assignments, where it'll say that you're messing with a parameter or trying to change the value of a parameter. So you don't want to do that. So in order to not do that, I'm going to set these three temporary or interim values of my red, my green, my blue into this. Actually, let's go new green, new blue, because these are the new values we want. And we're going to set those to the existing values. And we're going to do if red component is greater than 255, then we want to do new red equals 255. Else if red component is less than 0, then we want new red equal to 0. All right. And then otherwise, at the end of this, we will set everything up. So let's check for the red. Red. We're going to do a check green. One of the things you want to be careful about in this lab is if you're copying and pasting, you want to make sure that you're copying and pasting things correctly and that you don't leave another value. This is the typical error in this lab, is that you don't copy and paste everything over correctly and you leave one of the copies wrong. So make sure if you're doing cut and paste, that you're doing it carefully so that you're not forgetting to change these things over. All right. Then I want to go this dot red, because I'm working with a color here, and I want to say this red equals the new red color. This dot green equals new green. This dot blue equals new blue. And so what I'm doing here is I'm going to set up these values where I'm actually setting this to the new red component here that I've been passed in, and I'm going to set that up as new red. But I want to make sure that the new red is not over 255, and that's going to really mess things up if I do that and set it to 25,055. So we want to make sure we've got these as the right values here. All right, so getting the ceiling of 255 and the floor of 0. So I've done that for the red, the green, and the blue components. And then I'm going to set, after going through those three checks, this dot red equals new red, this dot green equals new green, and this dot blue equals new blue. So this should be my constructor here, and this should create a good scenario here. I'm going to go ahead and run this. So one of the things I can do to run this is I can come back out here to this, and up here, output this. I'm going to go ahead and reopen or refresh this. And now all of a sudden, all my colors are appearing because I now have constructors that are working, and this constructor is constructed, which was the same thing as we had before, a red. So FF0000, that's where we just have everything fully red. So that's the highest value of red in the red component, and that's going to be all red. We have all green, which is all FF in the green, which is FF is the highest hexadecimal number. So that's the hexadecimal number that is going to give us all green. Then we can have all blue here, 0000FF. That's the blue over here. Then we got combinations, and this is where we get into some of the artistic things of green and blue make yellow. So if you combine those two colors, green and blue, fully green, fully blue, we get yellow. Same thing if we go down to orange somewhere, you can get fully uh, red and fully yellow would be orange. But that's not necessarily going to be a primary color, RGB color, so we're not going to get that. Similarly, we've got the fully red and green here. We've got fully the cyan, which is the fully green and blue here, gives us that color there. So, and then if we get the fully red and fully blue, we should get some kind of purple color in there, this magenta in here, as we call it. So FF00FF, that's going to be that magenta color here, or a purpley color. So we've got this all set up now, and we're going to be able to run that. You can run that again at the command line where you go out to run this Java main to the output, and then you can reopen that output.html. I had it open already in my browser, so I just did a refresh, and it just gave me the new values of all the colors inside of there. The other way you can run this is over here. If I actually go run this in the main and run this piece here, it will actually show me all of this in here. And I could actually take and copy this into a browser, or in some places they've got this plugin for Eclipse where I can actually view this console as a browser. So that's a capability as well. As long as you're seeing values change in here, this is good enough for testing. So you could just run this main and kind of see the output here and know that it's running okay. Or if we wanted to redirect the output, we could come into here and do run configuration. And we could say we want to run this, and we want to give the arguments in here, and we want to give the program arguments, and we want to go main, and we want to run it to output.html. See if I can get this to work properly. Okay, and then let's see if we've got that. I think that's going to do that. Let's see if we've got that in here. Doing that, I don't think it's actually letting me. So my arguments in here. So what I want is, yeah, it's the output.html. So it's running this main to output.html. So that's what we want to do there. And if we run that, then we should be able to get this to go to a file called output.html. And then we'll be able to go view that output.html file as well. And we'll refresh this. And now we see this output.html. We can now click into there, and we can actually see this output.html file over here. So that's another way we can run this like that and see our output. So let's go ahead and do this where we go ahead and finish out the rest of this. Let's go into the lab again. And then what we need to do is we've implemented the constructor. We've compiled our files and run the main, and we've got the top portion of the HTML still working properly here. Yes, and you can add that command argument in JGrasp as well. So let me go show you how to do that as well. I'm going to go ahead and close this out here, and I will open up JGrasp with the same thing. So that's a good comparison and a good way to run this. So let's go into here. I'm going to go into my CS149 folder. Won't let me go into there that way. Okay, let's go back here and go into Dropbox. This is not going where I want it to. Let's try this again. But yes, you can do that from JGrasp as well, and I'll go ahead and show you that. Open, and let's go into here, and we'll go into the user So I want change and then I want box line all in a CS149 folder. And I have this all in labs. This in my lab 19 spring 20. All right, so I want to open this main.java, and I'm going to hit the B button to browse to the folder. And I'm going to go into this run arguments and say output to output.html. And if I compile this and I run this, then it'll run to here and it'll give me that output.html, and I can open that inside of the browser over here as well. So same thing as running in JGrasp. So that's the nice thing about setting up your project with that sources in the same place as the root. You can still run everything because everything's in one folder. You can run it inside of JGrasp as well. So in JGrasp, you would just come up here into this build run arguments, and this run arguments, and you would put this output dot greater than space output.html, and it'll allow you to run this main file here, compile it and run it, and it will run it and create and update this output.html. So and then you could come into here and edit your color 149 as well. So let me go ahead and switch over to here so that we can just keep going and get a couple more of these methods created, and then I'll end this portion and then go into some other pieces. And again, you can finish up some of these other pieces on your own. I'm going to go in and do at least one or two other, one other method in here so that you have one more example done. Implement the other methods one at a time, rerun the program so you can see what's going on. Okay. Over here, I think I want to do the lighten first because that's the first one that appears in here. I want to make sure that is running correctly. So I need to come into here. I've got toString written, add works. Then I want to come into here and let's do subtract, since this is going to be a similar one to add. So in here, the method returns a new color 149 value, the difference between the color and the other color. So I'm going to, again, set up this new red, new business here, and I want to set up a new color. So similarly to the add, subtract is going to do the same thing or very similar things, and it's going to return this new color, and I want to return new color when I'm done with it. And I'm going to come in here, I'm going to create that color. So I'm going to go new red equals this dot red minus other dot red. And that's how I'm doing it here. This other is the one I'm passing in here, or that dot red, if you will. So over here, I've got new green equals this dot green minus other dot green. And new blue equals this dot blue minus other dot blue. And notice I'm not worrying about the ceiling or the floor, the 255 or the 0. And I don't have to worry about those because my constructor, when I create this new color here, it's going to make sure that I have a value that is okay. So what I want to do here is then I want to finally do the creation of that new color. I set up a variable for the new color here. This was in the initialization, but not the declaration. So down here, I'm going to do a declaration, new color equals new color 149 sub new red, comma, new green, new blue. So I'm going to now create that new color. This will do floor and ceiling checks. Make sure this is less than 255 and greater than 0. All right. So I'm going to compile this. And I'm going to come over into main. compile this. I'm going to run this with the output.html. And now my subtract should be working where I've got a subtract, but I don't think I'm using subtract in. Oh, I am over here. So this is 0, 0, and hex, this looks like this. So white minus cyan is going to look like that, and it's going to be black here. So that, I believe, is correct. Let's go ahead and look at, I think I've given you a reference for the sample output page, what you should be having, white minus cyan. So this should actually look like this FF0000 when you're done. So you're going to want to make sure that your output matches that output when you're all set, when all is said and done. So make sure you've got those matching when you're done your portion here. Let's make sure this is compiled. Then I've got this running, and that this is actually changing. Getting that to go, that is not changing there. Let's make sure that I'm doing that by doing it from command line. Making sure this is right. Oh, this is a different version of Java from there. Okay. Let's do this then in Eclipse, because that's going to be happier with the compile from this. Okay, did it get my changes here to this? I think it did. Subtract color, yes. Okay, so subtract color there. And this, if I run this, okay, so this is now compiled in a way that it does not like my versions of Java that are being run against this thing. Let's go ahead and delete these class files. Yep, that's fine. That file, I'm going to go ahead and exit this because I can't go out to that command line and do it. So you should be able to with yours, and I won't worry about that. Let's go ahead and go over here, and then now let's see if we can get this to compile and run. Finding the main class because things have gone awry here. Let's go ahead and rebuild the project here. Let's see if we can get it to. See if we can't go out here and go up in here and recompile. All right, there we go. Let's see if this is correct now. Yes, so this is now updated and corrected, and this is actually running properly here. So I'm going to keep doing it this way just so I can verify that everything's working. Again, if you start in JGraphs, you should be able to finish there. I just switching between the two. They're using different versions of Java on my computer, so I need to get those aligned up, or else I can't switch between those two and compile between the two. So I'm going to go ahead and finish this out over here in the Eclipse. Let's do equals, and let's do the, we've got the dim, and the dim is written for us. So we've got subtract, dim was written for us. So let's go ahead and do the darken. So the dim here was we were going to take this method and return a dimmer color of the 149 value. Each of the red, green, and blue components is decreased by 20%. So this is going to be divided by 1.2, or subtracting 20% from each of these items. So we're going to do a similar thing by 32 down to a, so we're going to decrease this by 32. So let's go ahead and do this. Color 149, new color. We're going to get a new red, green, and blue. New red equals this dot red minus, and actually we're going to do minus 32. 32. So this one we should not need to do anything with a int mask because we don't need to mask this as an integer because it will be an integer. So we should just be able to take these values straight up without having to do anything weird or funky with them. All right, save this out. We've got this. We're going to return new color. Way too far up there. Okay. All right. So now if we've got that, and then we come over here and we run this, we should get this new piece here, and our new output file will have where we've got a dimmer blue here. And our dim is now working, whereas it was not before. All right, let's go ahead and go to the next one here. The next one here is we've got this darken value 32 down to a minimum of 0. Again, we don't have to worry about that because the floor and the ceiling are checked by the constructor. So we only need to subtract by 32 here our red, green, and blue components. And so similarly here, you're going to do a lighten here and brighten. To do those things, you're going to increase by 20% and increase by 32 here. I'll let you complete those pieces. And then the last one here I'll work with is this equals, because this is going to be an interesting one. So if we've got when quality equals false, if this dot red is equal or equals other dot red, and this dot green equals other dot green, and this dot blue is equal to other dot blue. We want to say equal here. All these, we are comparing these. All right, we can take this and put this to the next line here, so we can get everything in there. Then equality equals true. Otherwise, we're going to leave it at false and return a false. So we want to return equality. See if this is equal. All right. We now compile this. We come into the main now, and we can run this. Again, let's go ahead and compile it out here. And then I'll open it again out here. And does blue plus green equal cyan? And we've got blue plus green equals cyan is true in the reference, and that is now coming out correctly to true over here. All right. So that equals is now working. So these are the things you want to do to check as you go along the way. Make sure those are happening. You can finish out the lighten and the brighten two methods and then turn that into AutoLab for lab 19. Again, the word of the day purple, you should turn that into canvas as the word of the day. And then also, if you can, try and get this output.html file and submit that to Canvas as well. You can make multiple submissions to Canvas later, but with that, if you don't get that piece, don't worry too much. It's just 1 point out of the 10. So, but you should try and get that output.html to come out correctly and have your values come out. To that, I'm going to go ahead and end this part of this so that we can get on to the last portion, which is I'm going to go ahead and do, for the last portion of class, some pieces within the bat array 1. So I'm going to go out to bat array 1, and I'm going to do, actually not this, I'm going to go to array 1 as the category encoding bat. I am going to do this swap ends And there was another one I was going to do, swap ends and same first last. So those are the two I'm going to do, same first last and swap ends. Where's that other one? Same first last. So let's do this one first. Same first last is going to take me over here. And this is, I'm going to go ahead and set up a new project over here in Eclipse. So let's go ahead and do that first. File new Java project. I'm going to call this loading bat at array 1. And I'm going to set this up in here and finish. So I've got that. I'm going to set up a file new class, and I'm going to call this one, let's call this extras, and we'll call it that. We're going to put in a main section, and we're going to generate comments in this one. Go ahead and do this. I'm going to get rid of this extra comment at the top, since it always seems to add even more of an extra one. We'll call this bat array1 extras, extra coding bat examples for Eclipse and coverage testing. Let's go ahead and make sure we've got a period there. I'll keep my author in there at version 4-7-20, and I have the JMU honor code. And then I'm going to come into here and we'll do 2 items in here. I'm going to do one as this same first last. Again, I think I'll call this. No, I don't want to do that. Let's see. Paste in here. Yes. Okay. We're going to call this same first last. This one is going to do this, and we are going to copy this information to here. What we want to do is all of this. Let's just leave a period here, and then we'll give the description underneath. All right. We're going to go at param nums array int array of numbers. Return Boolean true if array is length greater than 1 and first and last are equal. All right. Go ahead and set this up here. Let's set up some stubs for this. We're going to return false in here. That's that. That'll be a stub for this. And then we'll get this next one here. I also wanted to do the same first last and then the swap ends. Let's go ahead and grab this guy. Do the swap ends method. And I think I'm going to do these all as static so I can call them outside of here. Static. Even though we don't typically do that in coding bat because they don't want things called that way. And here we are going to, and we're going to get an int array new nums equals, and we'll set it to nothing, and then return new nums. This is going to be a stub placeholder here for this. Like this, and actually create this out, swap ends. And let's see what we want to do with this one. We'll give it an array of ints. swap the first and last elements in the array, return the modified array. The array length will be at least 1. Okay, this is going to be at least an array length of 1. Actually, in here, we're going to modify this to say check array length if less than 1, return empty array. Okay, so we're going to return an empty array like this if we have a less than 1. So if it's null or 0, we want to return an empty array here. So that's what we're going to do in here, and we'll check for that later. So we'll return an empty array instead of doing the other portion in here. So let's go ahead and save this and make sure it's done. I'm going to go ahead and do here and complete out this piece. So here, we're going to go ahead and set up some tests for this. So in order to create tests inside of Eclipse, we're going to go ahead and set this piece up for let's go in here to I deleted this. Let's delete that. I didn't need that stuff in there. Okay. We've got this over here, and I want to go new JUnit test case here, and I'm adding a JUnit test case to this. I'm going to say new JUnit 4 test. I don't want to use this new JUnit Jupyter test because that's a little bit more advanced than we need, and JUnit 4 is a little bit cleaner and easier to run in here. So I'm going to go ahead and do that. I want to call this bat array 1 extras test. And I'm going to generate the comments, and class under test is bat array 1. And I'm going to go next here. And I want to test same first last and swap ends here. Yes, the word of the day is purple, P-U-R-P-L-E. So over here, we've got the bat array 1 extras. I'm going to go ahead and set up these two as the 2 classes I want to test. And I'm going to create final method stubs and generated test methods for those tests. So I'm going to hit finish here. And I want to add JUnit 4 library to the build path. Yes, I want to definitely do that. Otherwise, I won't be able to compile or run my code. So let's go ahead and do that. Now I've come into here and I've got this idea of everything being completed. I'm going to go ahead and change these imports just because I don't like to have this wildcard one here. We'll do this in here and have the import org.junit.test, and we'll stop importing it statically. We'll import it by the import org junit assert or junit test. All right, we'll save this, and we've got this. This is going to fail. Let's set up our default test for the class. So we set up this default test. Default test to test the class. And this one's going to be a public actually default test. And what we're going to do here is we're going to go new bat array 1 extras. We'll do that test, and that's going to give coverage for the actual class line 7 there. So that's what that line will give us, the class coverage for line 7. Over here, we're going to have some going to run for the test same first last. We'll set up some tests in here for that. Let's go ahead and look at the same first last. What do we really want to test in there? What we're really trying to test in that is we want to test some values if we pass an array, let's go ahead and set up test one here, and we'll have an array with int array nums1 equal to, and we'll go 1, 2, 3, simple test here, and this should give us an array of, or a return of false, because we don't have the same first and last. So this, we're expecting it to be false. Expected value is false, or in this case, let's go assert false, and we're going to set that up as assert false for this same, we'll call it bat array. It's going to be a really long one. Array 1. Yes, and it is past 9:15. Yes, I am aware of that, and I'm going to go ahead and continue. Even if you have to be somewhere else, you can come back and take a look at this. This is extra work that I just want to get recorded so that you guys have some extra stuff with testing and that kind of thing done. So assert false here. We're going to do bat array 1 extras. So if you have somewhere else you need to be, feel free to end the call here or leap off the meeting. I'm going to continue to do this piece just so that I can get this recorded for you guys. So bat array 1 extras here, we're going to call this one same first last, and we're going to pass it nums1, and we expect this to be false. So that's the assert false in there. A lot of these are going to be tested this way as far as assert true and assert false. So let's go ahead and set up another one that we're going to set up an assertion for true, nums2 equals, and we'll set this one up as 1, 2, 3, 1, and we'll say assert true. We're going to say this is true for this one here, where we call it for nums2. All right. Oh, yeah, okay. Let's do this one. We can get rid of that error. All right. So let's set up a couple of other tests to kind of get an exhaustive set of tests in here. What we want to set up in here is a 3 set here. So we want to set another one where the first and the last are equal. So 1, 2, 1. Let's go nums3 is that. And we'll set this up as true because that's how this should return. This is how you should be doing things, where you're actually setting up tests before you actually write your code. So that's why I'm doing this particular one this way, is to try and get all my tests written before I do my code. All right, so let's come up with some more cases here. We want to do one for 1 here, int array nums4 equals, yes, I will be doing an assert equals example on the second test set with the other piece there. So let's see, I've got this array. I'm going to set this up as 7 as the value in here, and I will get this one as assert true as well, because that should be true, and we're going to pass it in here nums4, nums3. We want that to be true, and then we want the empty case, nums5 equal empty case. All right, so let's do an empty case, and this should give us a false. So let's set up an assert false here. So let's do that. And then let's see. The other thing we can do here is you can also set these up as assert trues if we set up our expected as booleans, boolean expected is false, and then we can set up this assert equals, and we can set this up as a 2 items here as the test, we'll call it. We'll set up a integer array that is 2 items long, num6 equals, and we'll have this be lucky sevens. And we'll set this up here as expected, and we're going to set this one up as true. Should be that, and then we're going to say this value sub6. So we can also set that up as an assert equals with booleans, and that should work still too. So let's go ahead and do this check. Run this. We're going to have it fail everything, and this other one is going to pass because we don't have anything written for that. But this is a pretty good set of cases. I think this should be fairly exhaustive. We might want to have one more where we do some others that we have as really long items that are longer than 3 or 4, but 4 should be a good test right there. So this should cover a lot of what we're doing. Let's go ahead and write this method now. So same first last, what we're going to do is we want to check in here, and we're going to set up a check here to see if we are greater than 1, then we want to return num sub 0. So let's see, let's go ahead and set up if we are the same, we want to return that. Otherwise, we want to return false. So if the array length is greater than 1, nums.length is greater than or equal to 1, then we're going to want to return nums of 0 equal nums sub nums dot length minus 1. That's going to be the thing that we return, which is the expression of if these things are equal, these first and last numbers are equal, then we want to return true. And so this will be true if those two numbers are equal. Otherwise, we're going to return false, and we're going to return false if the length is less than 1. So this should work for all cases. Come into here and run our tests. Let's go ahead and run the tests here. And in fact, yes, that is passing all of our tests. And so that should work and be good for what we're looking for. That piece of code should work in there. The other thing we can do is come into here and run a code coverage, and we can see if our tests come in and actually cover our code. And here we're going to get a coverage, and we're going to come in here and we're going to see that we are not covering, let's see, 2 branches missed, nums length greater than or equal to 1, and nums length less than or equal to 1. So we should have that covered here in these tests here. Let's see why we're not getting that. Let's see if we've got the ability to do this in a little bit different way. And same equals false. Let's return same here. And we'll do this as if nums.length is greater than 1. And if here, then same equals true. And then we'll return same. All right, let's see if this will pass our tests. It's still not covering things. It's not happy with the coverage here. We have not covered these lines of right. This should be giving us coverage for that. And then we should get all of these covered. All right, let's go ahead and write the other tests for this guy here. So test 1. Here we want to test the swap ends. And swap ends, we're going to try and test things where we've got first last elements in the array are modified. So we want to set up some arrays and then even do arrays dot equals. So let's do a we'll have this array here, and we're going to have our expected array be 1, 2, 3, 4, and we're going to have it be 4, 2, 3, 1. And this one will be 1, 2, 3, 4. So if we're swapping the first and last elements, this is what we want to do. Then we're going to go and we want to do one expected and our call to our method, which will be that array extras. I shouldn't have named this this long dot swap ends sub nums1. And I'm failing this because these different, the actual length is 4 and the actual length is 0. Yeah. Okay, because I'm returning just a 0 in here or a null value in there. So that's going to fail right now. Good. All right. So let's set up some other tests here. So this is how we would set up our assert array equals in this case, because we want 2 array values in this case. So we're going to do 1, 2, 3. Let's do a 1, 2, 3 value here. Test 2. 2 equals 1, 2, 3. And then int array expected equals 3, 2, 1. Let's do expected 2. This, copy this in here, nums2. expected 2. All right. Test 3. Let's create one that's a little bit trickier. We're going to do 1, 2. Numbers 3 equals 1 comma 2. And this should be 2 comma 1. Expected 3 equals 2 comma 1. Let's go test 4 here. Set this one up here, and this is going to be one where we do a single value. Array nums 4. We want this one to equal 1. And then we'll say int array expected 4 equals 1, because that's going to be the same thing forwards or backwards. And we'll go into here and set array equals here, and 4 and 4. These are all of our expected values and our other values. Let's go into do our last one. Over here, we were going to, instead of doing all of that, check if array length is less than 1, return empty array. So we want to make sure that if we have less than 1, then we return the empty array. So we want an empty array here to test with. And null test 5 int array nums 5 equals the empty array. And we're going to have array expected 5 equal the empty array. And then test 6. Say nums 5, nums 6 equals null. And then we're going to say int array expected 6 equals the empty array. That's what we want to return, 6 and 6. All right. So now if we run this, we're going to get no test passing because we haven't written our code. Now let's write the code for swap ends. All right. So I'm going to say int array int temp equals num sub 0. Let's go if, let's do this, if nums is equal to null, or nums dot length is less than 1, and we want to return empty array. Else begin, and what we want to do is write some stuff in here. Let's do some stuff in here. Actually, we don't need to put this in an else. Let's just put this array swapped equals empty array. Actually, let's do this out here. Swapped equals new int sub nums dot length. So that's going to cover all cases of nums. And here we're going to want to return swapped. else? We've got this statement here, and we're going to want to return this as where we take the temp equals sub 0. Then we're going to say num sub 0 equals num sub nums dot length minus 1. And we're going to say num sub length, num sub nums dot length minus 1 equal to temp. All right, and that will swap the first and last numbers. All right, so if we've done this correctly, all of our tests should now pass. No, it's not letting me do that, so where am I failing here? 51, so expected 1 here. 6. Okay, so it is not liking this last call. So what if we just comment this guy out? Let's see if this will work for everything but null. Are we still getting? All right. All right, I think everything's in there. So I'm going to go ahead and finish that out. I think that's good, and I will correct any issues that I have in there and then post this piece. So I will go ahead and stop the recording now. So we're going to end this here.